Hello students, welcome back to the channel. So today we'll be discussing the electronic configuration of the first 20 elements. Now there's a question which comes that why does sodium arrange its electrons as 281? Why can't all 11 electrons stay in one shell? So today we will learn how to write the electronic configuration of the first 20 elements in the easiest way possible. So there is a set pattern of distribution of electrons. The first shell will accommodate 2 electrons. Second shell is accommodating 8 electrons. And the remaining 1 electron moves to the third shell. And that is how we have written the electronic configuration for sodium atom. So why this particular pattern is followed? Why it's written as 281? Why it's not written as 29? So we'll understand this concept. So please follow the rules because the rules are important when we are writing the electronic configuration. So earlier also when we were talking about the introduction of shells or orbits which was given by the scientists Bohr and Bury, they were the scientists which had given the distribution of electrons in each shell. Now the electrons stay in shells around the nucleus and each shell has a limited capacity or limited space to accommodate the electrons. These shells were named as K, L and M shells. Now K shell can accommodate 2 electrons only. Okay. L shell can accommodate 8 electrons only and M shell can accommodate 18 electrons. Now how we got these values? By applying the formula 2n square, we are able to calculate the number of electrons in each shell and n corresponds to the number of shell. Okay, n corresponds to the number of shells. So K shell is the first shell, L shell is the second shell and M shell is the third shell. So if we apply the formula, what will be the values which we will get? K shell will get 2 electrons. L shell will accommodate how many electrons? 8 electrons. And M shell will accommodate 18 electrons. Okay, so this was the rule which was given and we have to understand that the maximum number of electrons in the innermost shell will be 2 only. So the electrons will start filling from the shell that is closest to the nucleus. So this rule you have to remember that the first shell will accommodate 2 electrons only and the remaining electrons will move to the second shell. Okay, and at the most the second shell should have 8 electrons only. It cannot accommodate more than 8 electrons as we have seen for the example of sodium earlier. So remaining 1 electron is moving to the third shell. So because we are dealing with the first 20 elements for class 8th, we'll just discuss the configuration. Hydrogen, its atomic number is 1. So its electronic configuration will be 1. The 1 electron moves to the shell that is closest to the nucleus. This is the nucleus of hydrogen. And helium, its atomic number is 2. So the 2 electrons will be present in the shell of the helium. Helium, the nucleus is here. That will be the nucleus. Okay. So hydrogen and helium are the first 2 elements. So the electrons will fill in from the innermost shell first. Okay, so that is the simple electronic configuration of hydrogen and helium. Moving to the elements from 3 to 10. Now first list out the elements. So you need to remember the first 20 elements. So the elements from 3 to 10 are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So let's write their atomic numbers: 3, 4, 5, 6, 7, 8, 9 and 10. So if we have to write the electronic configuration now, let's understand. We have understood that the golden rule or the important rule to fill in the electron, the first shell will have how many electrons? 2 electrons. So how many electrons are left? 3 minus 2. 1 electron is left, that will move to the next shell. Likewise for beryllium, the first shell, the shell closest to the nucleus, will always have 2 electrons. So now how many electrons are left? 4 minus 2, the remaining 2 electron moves to the second shell. Then for boron also, first shell 2, remaining 3 electrons in the second shell. Carbon will be 2 4, nitrogen is 2 5, oxygen is 2 6, fluorine is 2 7, and neon will be 2 8. Now important point you have to observe over here is that neon has acquired a complete octet by having how many electrons in its valence shell? 8. Now the second shell is completely filled. So from the next element, the electron will start filling from the third shell. So what are the next elements from 11 to 18? We have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. Let's write the atomic numbers: 11, 12, 13, 14, 15, 16, 17 and 18. Now we have already seen that in neon the second shell is completely filled. Now the remaining electrons will move to the third shell. So if we see the electronic configuration of sodium, first shell is 2, second shell is 8. So total how many electrons have been accommodated so far? 10 electron. So remaining 1 electron will move to the third shell. So that is how we write the configuration for sodium. Same rule will be followed for the remaining elements in elements, that is from 11 to 18. Magnesium first shell, second shell is 8. So remaining 2 electrons in the third shell. Aluminium will be 2 8 3, silicon again 2 8, 8 and 2 is 10, so remaining 4 electrons in the third shell. Phosphorus will be 2 8 5, sulfur will be 2 8 6, chlorine will be 2 8 7 and argon will be 2 8 and 8 plus 2 10. So how many electrons are left? Again 8 electrons that will move to the third shell. So here argon has now acquired a complete octet. The third shell has got how many electrons now? 8 electron. So now the remaining electrons will move to the fourth shell. So that is how you need to practice writing the electronic configuration, and with practice you will become perfect in writing the configuration for the first 20 elements. So remaining 2 elements are potassium and calcium. Potassium atomic number 19, calcium atomic number is 20. So if we have to write the electronic configuration, first shell 2, second shell will be 8. So how many electrons have been accommodated? 10. So 19 minus 10, it means 9 electrons are there. You will say, ma'am, we'll write 9 electrons. So this will be wrong. The shell cannot have more than 8 electrons. So you will write the configuration as 2 8 8, 8 8 16, 16 plus 2 18. So remaining 1 electron will move to the fourth shell. Likewise for calcium also, it will be 2 8. You can't write 10 over here. That 8 and 2 10 and 10. The last shell or the next shell, whatever the next shell is, it cannot accommodate more than 8 electrons. So this will be wrong. So the configuration will be 2 8 8, 18 electrons, remaining 2 electrons move to the fourth shell. So that is how you have to write the electronic configuration. Okay. So only the first 20 elements you need to practice. Now let's see the arrangement of electrons. That is how you will draw the atomic orbital structures. That is important because in the examination you are being asked to draw. So always draw with a pencil using a compass so that your diagrams are neat. So first example we are seeing here is of carbon. Now carbon, we know the atomic number is 6 and mass number is 12. So what will be the electronic configuration? Electronic configuration we always write in terms of atomic number. So here the electronic configuration will be first shell 2 electrons, second shell 4 electron. And if we have to calculate the number of neutrons, it will be mass number minus the atomic number. So number of neutrons will be 6. So that is how in the nucleus you'll be showing the number of protons and neutrons. Okay, so that was the example of carbon. Next we will take the example of neon. Okay, neon atomic number is 10 and mass number is 20. Okay, so if we have to write the electronic configuration, again on the basis of atomic number, its configuration will be 2 and 8. Okay, so the first shell that is closest to the nucleus will have 2 electrons and the second shell will have 8 electrons. 4, 6 and 8. And if we have to specify the number of protons and neutrons, protons will be equal to the atomic number, that is 10. And how will you calculate the number of neutrons? Mass number minus the atomic number. So number of neutrons will be 10. So that is how you are going to specify the protons and neutrons in the nucleus. So that is how you will draw. First draw symmetrical structures and show neat representation of electrons in the orbits, so that you get full marks and your marks are not being cut. So this is a scoring part and you should draw the diagrams neatly. Okay, so we have seen the structure of carbon and neon. Sodium already we saw. So sodium we know its atomic number is 11 and its mass number is 23. Okay, so if we have to write the electronic configuration, it will be 2, 8, 1. First shell has 2 electrons, second shell 8 electrons, 4, 6 and 8, and the last shell will have 1 electron. So if we have to specify the number of protons and neutrons, protons will be 11, neutrons how we calculate? 23 minus 11. So number of neutrons here will be 12. So that will be the nucleus. Nucleus comprising of protons and neutrons, having 11 protons and 12 neutrons. So that was the example for sodium. If we take the example of aluminium, aluminium atomic number is 13 and mass number is 27. So its electronic configuration will be 283. Okay, 283. So the first shell will have 2 electrons, second shell will have 8 electrons, 5, 6, 7, 8, and the remaining 3 electrons in the outermost shell. So if we have to specify the number of protons and neutrons, protons will be 13, and to calculate the number of neutrons, it will be 27 minus 13, it will be 14 neutrons. Okay, so that will be the nucleus comprising of how many protons? 13 proton and 14 neutrons. So these diagrams you need to practice on a regular basis in order to become perfect in showing the electronic configuration. Next we will see the next element, phosphorus. We will not be taking all the elements, few elements randomly I am picking up, rest you have to draw and practice so that you know how you are drawing the showing the arrangement of electron. Now phosphorus has atomic number 15 and mass number is 31. So electronic configuration will be 285. Let's show the electrons. First shell 2 electrons, second shell 8 electrons, 4, 6, 8, and the last shell 5 electrons, 1, 2, 3, 4 and 5. So if we need to show the protons and neutrons, protons will be 15 and neutrons will be 31 minus 15. How many neutrons will be there? 16 neutrons will be there. So that will be the nucleus, which comprises of protons and neutrons. So always write the protons and neutrons. If mass number is given, you can easily calculate and show the number of neutrons. Okay, next element we will see is of argon. Argon has atomic number 18, mass number is 40. So its electronic configuration on the basis of atomic number will be 288. Okay, so if we write down the arrangement. First shell 2, second shell 8, 3, 4, 5, 6, 7, 8, and the last shell also 8, 4, 6 and 8. Now let's write the number of protons and neutrons. Protons will be 18 and neutrons will be 40 minus 18. So what will be the number of neutrons? 22. So number of neutrons will be 22. Okay. So I hope the structures are clear and how you have to write the electronic configuration. Lastly, we'll see the last two elements, that is potassium and calcium. So potassium, we know atomic number is 19, mass number is 39. Okay, so electronic configuration, it will be 2881. Number of neutrons will be 39 minus 19, 20 neutrons will be there. Okay, 20 neutrons. So let's see the arrangement. First shell 2 electrons, second shell 8 electrons, third shell 8 electrons, and the last shell will have 1 electron. Let's write the number of protons and neutrons. Protons are 19 and neutrons is 20. So that will be the nucleus having protons and neutrons. Okay. Lastly, we have calcium. Okay, calcium, we know that the atomic number is 20 and mass number is 40. Okay, mass number is 40. So if we have to 40, yes, let's write the electronic configuration. It will be 2882 and number of neutrons will be 40 minus 20, 20 neutrons will be there. Okay, so let's quickly write the configuration. First shell 2, second shell 8, third shell 8 and the last shell 2. Okay, so protons will be 20 and neutrons will be 20. That will be the nucleus. So that is how you are going to draw and practice. So I hope this video has helped you to understand in writing the electronic configuration of the first 20 elements. Please practice it. We'll see you in the next video. Thanks for watching.